Hello, welcome back. It has been a while that we haven't had any update for the TouchDesigner tutorial. So we'll come back to one of the very sophisticated way of working with the idea of motion interaction and as well as the physics of something look like a billiard or snooker ball playing around on the top of the table. So we'll try to explore how we can achieve with this one, but it will be a little bit different from previous tutorial because I don't have time to walk through from the beginning to the end of the construction. I just go through some of the important point, and then I will upload the final project to the Patreon page that together with the YouTube video that you can have a look for reference, and it's also make out some reason that I'm going to explain later and towards the end of the video. So let's start with the fun part first. So that is the overall construction, and then we can start with this. So in the very beginning, I have set the three keyboard control. The first one is 1 to initialize the physics, and then 2 to start the simulation with the ball dropping from above, and then to the ball to the tables. Okay, I also use black and white for the video, so because that one is for the visual feedback of what I'm using my finger to interact. So the third button I use is the key number 3, which can add something called momentary force to the individual balls such that they can move and spin in some random direction together for this one. And then we can start from the beginning and try to have the demonstration again. So the key number 2 will drop the ball to start the simulation. And then the fun part of this one is actually the MediaPipe that I use it to track my finger, each of the tips of my actually 10 fingers. So by using the finger and by touching and moving the ball, actually you can manipulate the ball. It's similar to actually touching the ball virtually, and then to move them around, and they can have the physical collision towards each one of others. And then the four boundaries actually is the rigid body that is stationary, that function as the four boundaries of the billiard table. So that is the simulation of this one, and so that is the final result of that one by combining your use of the MediaPipe, which I use my own version that using Python together with the model that you can download from the Google website, and then send the 10 finger position to random picks in order to check whether if any one of them are actually hitting on an individual ball in order to calculate the speed or change of speed of the movement. And the change of speed is done by a slope that calculate the current and previous position of individual finger in order to determine the direction of the force that drive the ball along with that particular direction. So let's have a look of the the TouchDesigner project. So the important thing is the video, and then I've reduce the resolution before I send it to the engine, and that engine actually I prepare the hand track. TOX is the component that you can find from the download, that if you want to have a look, you can download and import this one directly without using the engine, such that you can understand what's going on inside the hand tracking part. And the hand tracking part, of course, it requires the model that the MediaPipe use for the hand finger landmark tracking. So I use the engine because it's optimized the performance, because the one, if I didn't use the engine, actually they will run as like around half the frame rate. And then the output for the hand tracking is actually your fingertips. So 1 to 10 if you two hands, and then one hand will be 1 to 5. That's the UV, that's the position of your fingertips. I only track the fingertip, but not the other joint. Okay, and then the black and white one, the monochrome one, is actually placed on top of the table. So I also need to use the 3D to construct this particular box where all the balls, so at this moment 8 of them rolling around and hitting each other within this box. And the balls are defined by this one, and as an actor you can see from here, and it's also with the instancing turned on by using a line in the very beginning, where each one of them will align at a point on the line over here. And then if you start the simulation, the ball will drop onto the table. And the keyboard number 3 actually activates random forces, which I use only 2 directions, because the Y direction, which the camera view at this moment is, I put the camera like on top of the table, is pointing towards the origin, and at the same time the ball will drop onto the tabletop, and the table actually is in the X and Z direction, so the Y direction is the dropping of the ball, so that is the Y direction. Okay, so the random force by pressing the key number 3 is effectively changing the force X and for Z. So that is the key number 3. So the key part of this one is the result from the finger data from here. Which I also use a component here to use a loop in order to calculate something like the displacement of each of the fingertips, and then put it in feedback, and then to create the speed of the movement of each of the fingertips. And then with this piece of data, I concatenate back with the original U and V, that is position data. So I can further zoom in to have a look. So now we have the position data UV and dxdy, which is the speed or velocity of the motion of each of the fingertip. Okay, and all of those data I send it to a random pick, which accept the random one top as the location that I try to do the render pick action. So this is an DAT version rather than the chop version, with the only camera that I use. And then I don't track or return the position, but I just track the instant ID of the ball that's come with 0 to 7 because we have 8 of them. And then after the render pick, I customize a little bit of the callback function, which I use the dxdy, that the speed of each of the fingertip movement in terms of the magnitude of the movement and also the direction of the movement, because I have the X and Y direction. And also track the instant ID, and for each of the instant ID, like from 0 to 7, so I accumulate the dx and dy for them if they are hit by any one of the fingertip, and then that data will be accumulated into this table. So just for example, if any of my finger kind of hitting any of the ball, so the velocity data will be put into here in the 0 and 1. Okay, so that piece of data will be used in the physics simulation that is in here. So that is the callback for the bullet solver, that is the main engine for doing the bullet physics simulation. So other than using the button to initialize and start the simulation, I also have the callback around here for each round of the simulation. So I try to get the actor, that's each of the individual balls, and then for each of the instance, and then using the motion data from here, that's the tx and ty that obtained by the render pick information of the movement of my fingertips. And then to compute, the tx will use to control the force, that's how much force exercised in the horizontal direction, and the ty, that is up and down of my finger movement, actually convert into ez direction, because the table is kind of like horizontally, but my camera is kind of on looking from the ceiling towards the tabletop. So I try also add some random force for the rotation in the y direction as well. So that two forces, the impulse force. One is the direct force that drive the movement of the individual ball, and then the other will be a rotational, that's the torque. I also use the tx and ty from the motion table, and then to change to spinning of each of the ball in this case. So that is the key part of the physics simulation, that how we can use the MediaPipe motion data to enhance our experience of playing around with the ball using our fingertips. And the other are pretty straightforward, the camera, that I put it right on top of the table, like around 35 units, quite far away. And then the other one is another view. That is my black and white image, and put it on top of a grid. Just yes, and then just position it slightly in front of the tabletop to give us the visual response, but at the same time I disable it for the physics simulation. Those details would not interfere with the ball movement. In this case, I just use it to map my image on top of here. And then one other thing is, since we use instancing to the color of the ball, we're using the RAM with 8 pixel for the individual color, and the texture map, actually if you pay attention, that each of the ball actually come with a label, this A, B, C, D, E, F, G, and then those labels are actually from this component that I keep a table of 8 rows, and then in the start of the movie, and then we'll put each one of them into a texture 3D top, and then that texture 3D top will be used as the texture map for each of them by using the instancings around here. So that is the way that I put different label for each of the ball, and then the rest will be pretty straightforward. The keyboard control to initialize, and then yes, so that is the everything that you can try to play around with this one first. So if just in case you find it not easy to understand, I can consider to make a longer video such that we can explain a little bit of the working mechanism. So the overall presentation will be like this one. Actually, if you do not use your finger, by using other object like the bunny, since we are not using the optical flow, so that won't have any interaction unless you put your finger to move or to massage around them, so that you have the interaction. So that's it for today, and everything you need to use will be in a zip file that contain the hand tracking components around here, and also the MediaPipe model, and also this project file. And the reason that I didn't have a very frequent update to the Patreon and the YouTube is because of my schedule. And at this moment, I'm now in Kuala Lumpur, in somewhere in the location called PJ. And around a week or 2 weeks later, so I'll go back to Hong Kong. It's the place that where I grew up and work most of the time. There's not exactly this location. That's the Transformer scene that many years ago they have scenes of one of the Transformer series happening here. And by end of July, I'll be relocating to another city in London, where I studied many years ago, and hopefully will stay there for a longer period of time, and to looking for other opportunity as well. And fortunately, maybe in the future, in the coming TouchDesigner meetup, that I can also join to meet some of you. I understand some of our patrons are actually based in London, and a few months ago, I also present in the TouchDesigner Hong Kong meetup section that meets some of the Hong Kong patrons as well. So until I settle a little bit in London to resume the tutorial and the video making, so I hope you can enjoy the previous video or other tutorial, and then if in case you have any question, you can drop me a message. I try to answer or address as soon as possible. And until the next one, probably that I'm going to make in London. And at this moment, I wish you have a very happy adventure with TouchDesigner, and maybe with MediaPipe or physics simulation in this case. And we'll see you very soon in the future from another location in the world. Bye bye.